Hello, everyone. Hi. I'm Miguel. I'm going to skip the whole presentation stuff because, anyway. I'm going to be talking about PACT and consumer-driven contracts. I will try to go through this quickly. I know we're running late already. So, OK, let's dive right in. This way. OK, so consumer-driven contracts. This is a pattern to evolve services. Who's familiar with microservices here? A few people. OK, so it's not unusual that you have maybe 50, 100 services in your company working together to try to deliver a feature. I don't know for how many of you changing one of them can cause a lot of problems, and how many times you change it and you don't know that it's going to happen. So that's a problem when it comes to evolving. So consumer-driven contracts are a pattern to make that easier, to make the process of changing a service be independent. Like, if you need to deploy one service, you shouldn't care about any of the others. You should have a way to say, this is going to be working all the time, which is basically the purpose of QA and everything we do pretty much every day. Like, what you want to know is, like, I'm writing some code, and I have a way to make sure that's working. That's everything that you need to do. So that is consumer-driven contracts. A more formal definition is this. Basically, the saying is a pattern to evolve services where you have consumers that will create a contract to work with a provider that will then make sure that those contracts are met all the time. Every time a change is made, the provider will make sure that they are still supporting all of their clients. If you want to know more about this, you can visit this website. I will probably share the slide with you later on. So yeah, that's basically it. So next, this is the architecture of it. So just imagine you have, like, on this side, a service that is customer data. And that can be used by multiple clients. Let's say I have the billing service that will need information about the customers. I have the order fulfillment service that will use also information about the customer, and the marketing team that for some reason is the information about the customer. So what you do in this case is that each one of those services will create a contract with the provider. They can be used in this service in many different ways. So you don't know how all of your clients are using your API, let's say. So what they do is that they create a contract, they share with you, and then what you do every time you make a change is that you go to that common repository, you grab those contracts, and you verify them against your service before you push it to production. If there is an error, you will know before breaking the clients. One of the important things is that when you know how your clients are using your service, this is, like, really valuable. You know exactly what they're doing. Maybe you have a feature that no one is using, and you spend weeks developing and maintaining that you know that no one cares about. Then you can just get rid of it. Maybe something that you think is not important, someone is using it, and you know that you need to pay more attention to that. So that's basically, apart from the fact of evolving the services, this is also, like, a really important point when it comes to consumer-driven contracts and PACT, which is the next thing we'll talk about. To do this, obviously, we need tools, a common language to write the contracts, which is a way that the consumer will understand and the client will understand. For this, we have the PACT framework, which is a family of frameworks to support consumer-driven contracts. If you want to know more about this, you can visit PACT.io. It is available for C#, Java, Python, Ruby. Pretty much every major programming language has support for this. So yeah, what I'm going to do now is to do a quick demonstration of how this works in practice. Hopefully everything will go well. So can you guys see this? OK, that's fine. So this is a GitHub page. I will just try to follow this to see if we find any problems, because the point is that if you want to do it, you could just go to the GitHub repository and just follow this thing and get like a better of an insight in how this works. So let's go. So first, we need to clone the repo. Already did that. There is a tool called a path broker, which is what we use to share the contracts between the clients and the providers. I already have that running. We can take a look at it here. This is the path broker. Here you will have a list of consumers that will say, this is the consumer of this contract, this is the provider of the contract, and all that information. Okay, so let's do this. I will need so I'm just going to show you first. Actually, I'm going to follow the page. So we need to have the two services running. I have two services. One is the meme service, which is serving memes. And the other one is the memes website, which is just a website that displays a meme. You can see this is the service, the API. It's really simple. If you pass a meme ID that doesn't exist, tell you that it doesn't exist. If you pass one that does, it returns the URL. And this is the website. Every time you go there, you will see a different one. Hopefully. Doesn't look good for local host website. Let's try it again. Okay, it's working. So yeah, this is the infrastructure that I have. This is when you guys were supposed to laugh. We talk about this, it says funny. Okay, so these are the two services. So what I did is that I created a contract between the website and the service. And I'm going to show you the contract now. Maybe I can just make this a little bit bigger. Yeah, that's probably better. So this is how a contract would look like. For developers, that would take away the need of writing any other test. What you do here is that you describe every single request that you're going to send to the service and what you are expecting from it. So in this case, I'm saying, there's some Python particular stuff. But in this case, what I'm saying here is like, when I send like a request to the meme service with an ID that doesn't exist, I'm expecting this error. Then I have another test, which is when I'm sending an ID that actually exists, then I'm getting this reply. And it is that simple. Then what happens here is that when I run this, I have what is called a path mock that will capture all of the requests and will save them in a JSON file. That we're going to do that right now so that you can see it. Well, I have the file right here already. Yeah. So we'll create a JSON file like this. We'll say, I have this provider with this consumer, and this is the description of everything. You can say what status code you're expecting, the body of the response that you're expecting. This is really static, but you can do like really, you can match whatever you want. You can use regular expression. You can use like, it will be a random number. It will have this specific format. You can do whatever you want with this. Okay, so I'm gonna skip the part of creating the contract because I already have it here, but one that I cannot bypass is once I have the contract, I need to share it. I need to put it in a place where the, okay.
Yeah, I thought that might happen. I'm just going to see if hopefully. Let's just switch it back on. Yeah, it kept warning us. I wasn't sure what it was going to do because I'm not that familiar with this room. Bear with me. wait for that to turn on. I think it's just got a timeout thing. Hopefully that'll come back shortly.
Yeah, hopefully will give me time to finish before the next shutdown.
It's coming. It takes a while.
Okay, it's coming. It's coming up. Okay, so we're back on. Okay, so if you see here, we don't have any contracts here. So what I'm going to do is I'm going to upload the one that we have right now. I put together a little make file to just do this quite quickly. You can see what this is doing. It's just taking that file and sending it to that server. This is the code. Yeah, so I'm going to do that. Just telling that it's done. Now if I go to that website, here it is. Now I have a contract between those two services. And there are a few cool things here. The first one is that if I click in any of the services, I will get this beautiful map of all of the clients that are connected to that service. So here are just two, but imagine in an infrastructure of like 50, you would know who's talking to who. And we spent a lot of time trying to map that out at Babylon once, and then like 10 seconds later, there were like 10 more services already there, so it was outdated like in 5 seconds. So yeah, this is like beautiful and really useful for me. Another cool thing about this is that you get one thing that we all love and hate. Documentation. You will get this straight away. You will have a description of how you're meant to use the service, what's going to happen for all the requests that you can send. You can be lazy and not have all of them there, but if you do, you're just providing your clients. Also, when I mean clients, I mean like internal. This is not really great for like public APIs. So yeah, you will have all the information about the service here, and you can check this in different ways. You can make changes. Also, you can make like a request from here straight away. So yeah, I think this is really cool. Fine, so the next step in this process would be to verify that contract and see what happens. So I also have like another make routine to check that quickly. So if I go and I say make verify pack, well, I'm going to show you the code for this because it's important. This is actually going to the path broker and taking that contract, downloading it, and verifying it against the service that I have running. Important thing, just let me show you here. This is the code for the service, right? This is this one? Yeah. If I go and I change something here, let's say that I decided that instead of returning a single error, I want to return a list of errors. So I'm just going to modify that here, right? So this is now returning a list. When I go back and I do this, bang, the contract is not met. You cannot deploy the service because that would break everything. And yeah, that's it about pack. That was the demo time. Looks like everything went well. Let me see if we can get another 20 minutes. Yeah, happens all the time. Okay, so to continue with this, questions?
In regard to automation, how do you could you put a pacto? You call it pacto? What is pacto?
Yeah, it's a contract or pack, the name.
Can you add the automation pipeline to fair the automation?
Yeah, this is.
The delivery?
Yeah, the whole point of this is to have that kind of test automated and make it easier. Yeah, this is all automated. This is.
Part of the pipeline, right?
Yeah. Yeah, what we do at Babylon is that when we're deploying a service, we get like all the contracts for that service and we verify all of them. If that fails, we don't do anything else because there's no point. Anything else? Yep.
So what you've shown there is like the kind of the enforcement of an interface. But what I've experienced more of a problem with these kind of service architectures is that what happens when you basically when you're posting data. So if you're posting to a service and then what you need to verify is that the change in the objects on the service is what you expect it's going to be. Can you enforce that kind of thing in fact?
Yeah, there is a thing called provider states here, which is that you basically say, I am expecting this to be the state at this point, and after doing this, I'm expecting this new state. It is built in the framework. Yep.
Yeah, hi. By the way, I used to work for Babylon. Yeah, great company.
Not a little bit of sarcasm there, but.
Okay, so the question is, I'm a big fan of the JSON schemas, and that stuff remind me like a JSON schema functionality. And eventually, if you use JSON schemas, you can build mock of it for Java, JavaScript, PHP, Ruby, whatever. But can you build mock from your contract to mock your APIs? Like you don't want to spin everything to test a simple things. So you create mock of your response or request and deal with it instead of requesting or waiting for response of real service.
I haven't tried to create mocks out of this, but the whole point of this is that you don't have to, because you can just verify the contract. Why would you?
Yeah, but then you need to spin both services.
No, you don't need to spin both services. This is the point. When you're creating the contract, there is like the pack mock that is in between them, and it will just do what you told it that it should do. It will do that all the time. It is like a mock, but it will be in between. The only time you will only call the service when you're verifying it in the provider.
Okay.
So you will never need to have actual communication between the two services when you are writing your test.
I see. Thanks.
I don't know if we have time for more questions. I think that Phil said that all the questions for everyone will come at the end, so I don't know.
I mean, if anybody has another couple of questions, we're cool for time. We've got like
Okay,
20
cool.
minutes of networking after, so
Okay.
if anybody has a couple more, we can do two more.
Just have one.
Cool,
I
man.
have one more. When it comes to, because I imagine this is essentially for API testing, right?
Yeah, you could use it for everything, for any communication that you have between services.
Does it adhere to any standard, like OpenAPI, Blueprint, or
Sorry?
does it adhere to any API standard, like OpenAPI or Blueprint?
No, it's not. There's not really a standard. It's just JSON communication. As long as you use JSON, it would work. That's it? Well, thank you. This is my email if you want to get in touch. And one more thing. Just saying. Well, thank you.